Hi everyone. In previous video I have discussed about the basic elements of optoelectronic devices and few concepts in the solid state physics. In this video I am going to give a short note about the display devices and what are the luminances available in this display devices. So these are the topics that I am going to discuss today. So the today's topic is about luminance and the types of luminances. In general, we can define or describe a luminance as it produces spontaneous emissions of light radiation from a solid whenever we applied some form of energy in the medium. Here there are four types of luminances are available. First one is about photoluminance, which arises due to the absorption of photons, and catholuminance, it occurs due to the beam of electrons occurrence. And third one is about electroluminance, which results from the applications of electric field. So here the electronic transition between the two energy levels are E1 and E2, and the emission of radiation of wavelength lambda, where h nu divided by lambda naught, that is equal to the difference between the two energy levels. So now we will see about the first step of the luminance, that is a photoluminance. So here the energy is transferred to the crystal by absorbing the photons. Here the activator ion itself absorbs the photons directly. It might be expected. Why? Because same energy levels are involved in absorption concept. Here the wavelength for absorption and emission should be an identical one. In the real fact, the peak emission wavelength is invariably shifted towards the red end of the spectrum when compared to the absorption spectrum. So this phenomena is called as the Stokes shift. So here this diagram illustrated the assumed impurity site structure in a characteristic luminant materials. So here the graph shows the variation of wavelength with respect to the intensity between the absorption and the emission. Because of electrostatic interaction, the position of energy levels of the activator ion will always depends upon the value of R. So it will be true for the excited state also. Here the instead of single absorption over the emission, the wavelength, a band of absorption wavelength is seen. So further, while considering the amplitude of the oscillation, which increases by increasing the temperature, we could expect the width of absorption and the emission bands will also get increased by increasing the temperature values. So that is the main concept of photoluminance. That is how the absorption of photons occurs. The second method is about cathodoluminance. So here the cathodoluminance occurs due to the excitations of the beams of electrons. So here the emission process are same as that I outlined in the photoluminance concept, but here the remaining electrons which present in the energy level band will lose its energy, which may be bound electrons to be ejected from their parent ions. These secondary electrons in turn may generate the further secondary electrons produced by applying a sufficient energy to overcome or cross the forbidden layer. The final stage in the energy losses consists of an excitation of electrons from a state to the top of the valence band to those at the bottom of the conduction band. So here the cathodoluminants are explained with the help of the cathode ray tube. So this picture is very similar to everyone. Why? Because we have studied about this cathode ray tube in our physics in our lower classes. So here this is the structure of the cathode ray tube. In this we are applying an external voltage, external supply. So that is going to the electron gun. So here this electron guns is used to control the flow of electrons. Where the small grids are present inside the electrons, it will control the flow of electrons. Due to the external supply, that means the electrons are generated by the external thermionic emissions. The electrons get generated and flow through the electron gun. So here the grids are available to control the flow of the electrons. After controlling, it is passed through the deflection plates of X. So here the beam deflection plates are controlled by the electrostatic or the electromagnetic field, which acts as the right angle to the beam direction. So here the electrostatic deflection enables the highest beam which is deflected that was achieved when the electromagnetic deflection enables the higher beam accelerating potential which is to be employed. So whenever a beam strikes the screen, automatically the radiation is generated by the cathodoluminescence. The screen consists of a very thin layer of a small phosphorus granulars with a layer of aluminium which is evaporated on to the gun side. So this is the cross-sectional view of the cathode ray tube screen, which consists of the evaporated aluminum layer and phosphorus particles and a gas phase plate. So here it serves the two purpose. One is uh, it prevents a charge build up on the phosphorus particle, and second, when it get it get reflect the light which is emitted in different or directions, which is away from the observer, and also emit back to the particular thing. So this is the working principles of the cathodoluminescence. Here it shows the thickness of the aluminum and the phosphorus layers, basic geometry of that layers. Here whenever the aluminum layer is too thick, then automatically the electron beam will absorb the energy which is present in it. When the phosphorus layer is too thick, then scattering and absorption or reduces the output light. So this is the basic concept involved in the cathodoluminescence and the cathode ray tube. So here the color display for the home video viewing are obtained by using the shadow mask principle. So here the shadow mask principle state the three electron guns are used for slightly inclined to each other so that the beams could coincide at the plane of shadow mask. So this is how the color displays are occurred. So the next type of luminance is about electroluminance. So here this it is classified based upon the type of the drive. So here we are classified into two things. One is our AC electroluminance and another one is DC electroluminance. So here the phosphorus powder is suspended in the transparent insulating binding material of high dielectric constant, and it is sandwiched between the two electrodes. So here the two things are here. One is AC and another one is DC. So here the several possible emission mechanism that has been generated because of high electric field within the phosphorus particle. And here the enable electrons from the occupied acceptor level to the tunnel which has the same energy in the conduction band. And another possibility about the electrons which is moving in the electric field may acquire a sufficient energy to enable it to excite an electron from a valence band to the conduction band. So final result is it becomes quickly trapped at an impurity acceptor site, thereby effectively empty in a grid of an electron. So electron in the conduction band then make a radiative transmission by falling on the empty acceptor level. So that's all about the concept of electroluminance. So we will discuss about the injection luminance in the next video. Thank you.